So lecture 34 under unit 4 traffic management practices at worksite. So in that we are going to see about the intelligent transportation system applications in traffic management. This is content beyond the syllabus. What is ITS? So intelligent transport system is an advanced transport application aiming at providing innovative services relating to different modes of transport to improve safety and operation of traffic condition and enable various types of users to be better informed about the traffic and travel condition in order to make the traveler's journey safer and efficient with the help of smarter use of transport network. So what they are trying to say is this ITS is a tool which can be used for any mode of transport. It is not only for road transport, it may be for railway also. Now we are using for railway booking and all IRCTC website. Similarly, we have a rail tracking system. So through which the where the rail is located, we can able to see clearly through GPS. So these are advanced information systems using advanced technologies. So these all come under ITS. ITS is a system in which information and communication technologies are applied in the field of transportation engineering, including infrastructure, vehicles, and users, allowing the provision of online information in all areas of public and private administration. So here three main stakeholders they are insisting. First, that including infrastructure. First, from infrastructure, we need to collect data, and from vehicle some modules we need to install like GPS to tracking vehicles and all. Similarly, users must have certain apps so that they can receive the information. So these three are well connected. Then only effective ITS can be able to implemented. So this is usually done by the government, since huge data is going to be collected and stored, so the data theft is maybe possible. So for that purpose, the government has to take necessary steps to implement this ITS. ITS for traffic management. So traffic management is essentially adjustment of the demand and supply of the traffic network in time and space to better match the traffic demand and supply, that is capacity. So what they are saying is the demand is what is the vehicle actually going. So now you can count the number of vehicles per hour. Similarly, supply, the capacity is also measured in vehicle per hour. So each road and depend upon the lane configuration, width of lanes or number of lanes, the capacity is going to change. So we need to compare the demand and supply. So V by C ratio, the volume by capacity ratio should be always less than 1 even during peak period. Then only the road can able to cater for the required demand. Traffic management measures are required to improve the safety and flow of traffic, reduce traffic emissions, utilize traffic artery capacity more efficiently. So this ITS is further improving this capacity management fruitfully, so that the people that effective existing infrastructure can be utilized more effectively. So it is ITS is one of the major pillar in managing traffic with the existing capacity. For example, in construction site, if you see they are closing the road street, say one of the lane they are closing, or they're diverting the traffic to some other roads. So this kind of information we need to pass to the road users well in advance, so that people or driver may take some other route to reach their destination. So obviously the information once passed to the driver, the experienced driver take alternative ways to reach their destination. Thus we can manage the demand with the existing supply. We can utilize. Traffic management is used to manage and control the demand for transport and decides the selection of the mode of transport route, or the time of travel of transport. See, once the information is given to the passenger, he can choose, he will choose, okay, my travel time with this car is this much. So whether he will choose the private mode or a paratransit like taxis or public transport, he will decide based on that information given. It is generally customary practice that before embarking on capital intensive transport development projects such as building metros, the city authority tries to optimize existing transport and supply with the application of traffic management techniques. So before going for the budget, suppose if a metro and rail require more cost, we were taking such decisions using ITS tools. The traffic manager or traffic engineer try to manage the traffic within the existing facilities. Then if it is going beyond that, then they can go for some other alternative transport modal operator, that is choice, right? So since it costs more, broadly, the traffic management comprises the following elements. One is the information. They collect information from the field. They collect and control the traffic based on signals. Incident management, if any something happened, that need to be passed to the road users. Demand management, driver support, and monitoring. So these are the major components of any ITS traffic management system. And fleet and transport management is also possible. Fleet means here the public transport fleet sizes. So depending upon the demand, the fleets need to be operated. For that also, ITS is very much helpful. There are automatic uh, ticket um, automatic ticket counters are there that automatically count in which route the maximum demand it estimate and gives to the operator. So accordingly, you will run the bus or any public transport system. Automatic ticket tellers. So some of the examples of traffic management measures are variable settings for traffic lights, variable speed limits, especially in the work sites, they change the speed limit. Variable message signs to display any kind of messages. These variable signboards, message signboards are very much important. Parking guidance, dynamic lane management, dynamic route information. So these are overhead VMS through which we can able to manage. Many traffic management measures are increasingly using information and communication technologies to improve its effectiveness and optimize the cost. So finally, what we are going to achieve, we are utilizing the infrastructure more effectively, and we are trying to reduce the cost. First thing, the advanced traffic management system, ATMS in short they say. The ATMS is developed to integrate various subsystems such as, so CCTV is required for ATMS, vehicle detection system. So the system identify what kind of vehicle it is, whether it is a bus or car or two-wheeler. Communication system, cables through Wi-Fi or through cables, communication system, variable message system. So there is a traffic control center always be there that collect data from the field through communication system, and they display the information through VMS into a coherent single interface that exhibit real-time data on traffic status as shown in figure, and predict traffic conditions more efficient in the operation. So you can see in this picture, reduce speed, construction work ahead. So this kind of immediate the dynamic messages can be displayed through these digital boards. So the road users can able to adjust accordingly. One of the advanced traffic management systems is a computerized traffic control signal system, which is increasingly being used to analyze and manage present traffic situation, examines signal system problems, and implement or modifies signal timings remotely. So what they are trying to say is, a traffic signal system is there that is more adaptive traffic control system. That means based on the traffic demand or queue length, the green time of a particular arm of a junction got increase or decrease. So it is more dynamic. So in India, we usually use a fixed time signals where the green times are fixed irrespective of queue length. So what will happen? The people or those who are standing on the queue may get irritated and they try to violate the red signal. So this is one of the major cause for violation of red signals. Whereas in this system, there is a CCTV camera is there, it automatically predict what is the queue length. It processes the data through image processing unit and adjusts the green time automatically, dynamically. So in the well-developed countries like Canada, in Toronto, they have adopted the two kind of computers traffic control system. One is the transient traffic control system. The another one is split cycle offset optimization technique. The SCOOT is a very familiar system in many countries. In Britain and European countries also, the SCOOT system is adopted. If one wishes to install adaptive traffic control system for some junctions, vehicle activated signal system for some junctions, semi-activated signal system for some junctions, and area traffic control operate for rest of the junctions. So these are different kind of signaling system can be adopted for efficient operation of traffic in a city. The advanced traffic management system should be combination of all these systems. So this ATM is nothing but not only CCTV, information, traffic control center, collection of data, analysis, and this also coordinate all the signals in a country, in a city. For example, if a city is having a grid pattern of road network with 80 signals or 100 signals, all the signals can be controlled through one single traffic control center, where in the main server all the signals are interconnected with the local signal through local controllers. So a person sitting, a traffic engineer who is sitting in the area traffic control center can able to control any of the signal, that is 100 signal in the city. So you can also able to see the monitor the traffic situation through CCTV cameras. So in front of him there are a lot of monitors may be there. So you can able to monitor the traffic situation dynamically. So accordingly you can able to change the traffic signal timings. The system detect the vehicle on network and optimizes the traffic signal settings in project area to minimize travel time of most of the vehicles, decreases the queue length of vehicles at junctions with the facility of green wave and public priority system. So that is also possible. Since the CCTV camera is there, they can able to predict the public transport system, buses, and if any GPS is there, they can also able to track the public transport system. And once the bus reaches the junction, automatically gives green for bus. Okay, so the priority is given for bus. So naturally people use public transport system instead of private modes. So this is also possible through this ATMS. Apart from integrated ATC, the major benefits of ATM is real-time feed to variable message signboard system, display up-to-date information to road users, which reduce frustration of drivers. So if some incident happen, automatically naturally it is communicated to the driver through VMS. So up-to-date information is available with the driver, so you may not get frustration. So you can see here the night work ahead. A signboard is kept. This is the typical variable message signboard, digital signboard. So whatever message you want, that can be displayed using this VMS. This impatience sometimes converted in form of incidences or accidents or road rage. Thus, VMS is very helpful for the road users and also results in saving the travel time, which ultimately helps in reducing air and noise pollution. So VMS also offers an opportunity to driver to change the route on the basis of information provided. See, simple digital signboard if you install um, in a road network, so we can display the information well ahead of the road, so that saves so much. It reduces the pollution, noise pollution, air pollution. Also drivers, if she wants, she can change the route, some other route. So fully choked some roadway, so that can be communicated immediately to the road user. So you can choose appropriately. references. Thank you.